Properties of logs. So what we're doing today is we're going to apply basic properties of logs, and we're going to expand and combine log expressions and use the change of base formula. So the properties of logs are pretty much the same or similar to exponential, and they apply to natural log also. So there aren't separate ones. But when you have the product property, so the product property is if you're multiplying two things, then that means you're adding their logs together. Make sense? So here I have log base 3, 9x. That means I have log base 3, 9 plus log base 3, x. Quotient, if I'm dividing two things with log, then that means I'm subtracting their logs separately. Power, the power again becomes the coefficient. And then equality. So for equality, if I have two logs with the same base and variables have to be equal to each other, same thing here. That means that if the two logs, same base, that means the expressions have to be equal to each other. And then you just solve for x. Okay. Any questions about log properties? I will be posting this also, so don't feel like you have to write them all down, because then you can write them down later if you didn't get it all down right now. None? Then we will proceed. All right. Pretty straightforward. Simplifying and using the calculator. So here, showing you that instead of having to type log 7 plus log 4 in the calculator, if you multiply 7 times 4, all you have to do is type in log 28. Do y'all need to see me go through the calculator, or are y'all okay seeing the work? We're good? All right, thank you, Zane, for the thumbs up. Same thing here. I'm subtracting two natural logs. Instead of putting two natural logs in the calculator, I'm going to divide 25 divided by 5, and I get 5. And this is all I have to input in the calculator. On some calculators, it's not easy to access the power. So most times you may only have the square or whatever. So if I'm putting in log, if I don't have access to the power, as long as I change it and make it into the coefficient, then this is all I'm putting into the calculator. Okay. What makes this possible? This is my product. This is the quotient. And this is the power rule. Questions? None? All right. All right, so when it says expand each expression, that means you want to go from one log to multiple logs. So in order to expand this, I'm going to think about the product rule. And the product rule says that if I am multiplying two expressions within a log, that means that I'm actually adding their logs together. So my expansion would be natural log of k plus natural log of z. So far, still with me? All right, here, this is an example of the quotient. And the quotient rule says that if I am taking the log and the expression has division, that means that I'm actually can take the log of the numerator and subtract it from the log of the denominator. So easy peasy. Last one here. I have quotient and power all in one. How do I know it's power? Because the cube. So the first thing you're going to do, so we're using quotient and power. First, we're going to rewrite it so that it's all power. So we have log x 3 to the half divided by k. So when I expand this, I'm going to expand it slowly just so you guys can see it. So the first thing I'm going to do is write them as subtraction. And then I'm also going to now apply the power rule. So notice I follow quotient and power. So 3/2 log x minus log k would be the fully expanded. How do we feel? Still good? All right. Let's do a little more. Okay, so now we have variables and coefficients, constants, all involved. So here I'm going to expand. So my plan for expanding this, I'm going to look at it and see what I have. Well, I have product and power. So I know I'm going to be using product, and then I'm going to be using power. So product leads me to addition, log base 2, 4, plus log base 2, y to the third. Power means that I'm going to take my power and becomes my coefficient. Okay. Now, if it doesn't take this, that's because it wants you to actually simplify 2 to the log base 2, 4. That can be simplified. You're asking yourself 2 to the what power equals 4. So 2 to the what power equals 4. 2. So this actually simplifies down to . And that's what it's going to want. So yes, I understand that this is fully expanded, but when you can simplify, you must simplify. Make sense? Still good? All right, let's get a little crazy. So looking at this one, we have product, we have power, and we have quotient, right? All 3 in 1. Okay, so I'm going to rewrite this as z to the 1/2. And now I'm just going to start doing it piece by piece. So in my numerator, it becomes natural log of x plus natural log of y to the third. Correct? Minus, because it's quotient, my denominator, which is natural log of z to the 1/2. I'm going to keep expanding and putting the natural log of x plus 3 natural log of y minus 1/2 natural log of z. And that's the full expansion. So do you see how we apply the power product rule, then our quotient, then our power? No questions? No questions? We're good? All right, cool. All right, let's try a bigger one. So now we have 2x plus 1, the square root of 2x plus 1 over x plus 2 squared. So for this one, what we're going to do is we're going to rewrite it as powers. So we have log. Oh, sorry. Log erase, there we go. So here, it's quotient. So quotient is going to lead us to log, and I'm going to write it 2x plus 1 to the 1/2, because that's what square root is, right? The half power, minus log x plus 2 squared. So we use the quotient rule. And then what's left for us to use? The coefficient, the power rule, right? So with power, we're going to have 1/2 log 2x plus 1 minus 2 log x plus 2. And that's because of the power rule. All right, so now we're gonna go backwards. So we're gonna go from expanding to condensing. So how can we condense? What would be our plan of action to condense what we see here? What rules would we be applying? Multiplication. So it's the product rule, right? So we're going to start off with the product rule. And the product rule tells me if the logs are the same, that means I can multiply the two, right? So when I have natural log, I'm going to have 4e squared times 3e to the negative 2. And that's because of the product rule. I'm going to clean this up. So I have natural log of 12 and e times e to the negative 2 is what? E to the 0, right? Because when you are multiplying powers, that means you're adding them. And 2 plus negative 2 is 0. And then we're just going to simplify. So we simplify. I did it so that you didn't think I just got rid of the e. No, e would go away because e to the 0 power is 1. So I'm just going to be left with the natural log of 12. Well, we did e squared times e to the negative 2. And 2 plus negative 2 is 0. And anything to the 0 power is 1. All right, let's try another condense. So again, I'm condensing and I'm going to use product to condense. Agreed? How do I know I'm using product? That little guy right there. So we have log 4x times 2x is what product leads me to. That gives me the log of 8x squared. And that's it. Can't make it any smaller. Okay, let's try another. This time, because it's subtraction, that lets me know I'm going to be using division. I'm going to use the quotient rule, right? So quotient, it's going to give me log base 2. The first number represents my numerator, and the second number represents my second expression represents my denominator. So I have x to the 4 over x. And then you want to simplify. So when I simplify, what am I going to end up with? What do you do with the powers when dividing? Subtract. So 4 minus 1 is? So my becomes log base 2 x to the 3rd. So we use the quotient, then we simplify. Good? All right, let's put them together. So putting it together, just from what we see, we're going to be using what? We're going to have to use product because of the addition and quotient, right? Because of the subtraction. So just like you read, you're gonna read this from left to right. So what are you doing from left to right? So product tells me I'm doing what with the 3 and the 6? I'm going to multiply them, right? So that's gonna be my 6 times 3. And they're to the left of the subtraction, so that is my numerator. And then I get to the quotient, and quotient tells me I'm going to divide, and the value that's in the denominator is 9. So I'm going to simplify, and I get log of 18 divided by 9, which equals log of 2. How do you feel about it with just numbers? Okay, now we're gonna do it with just variables. Well, and numbers, but now we're going to first, when we see this, when there's coefficients, we want to use the power rule first. So we want to start with the power rule. So with the power rule, I know that this 4 is going to become here. This 1/3 is going to come here, right? All that's going to take place. So I'm going to be left with natural log of x to the 4 minus natural log of y to the 1/3 plus natural log of z to the 1/2. How do you feel about applying the power rule? Okay, after I apply the power rule, now it's just like the previous problem. We work it from left to right. So I have x to the 4 divided by, so natural log of x to the 4 divided by y to the 1/3, and then times z to the 1/2. Because I read it from left to right. Quotient, product. How do we feel? Okay, and we're gonna write it using radicals. So you actually want to write the radicals. So I'm gonna write natural log of x to the 4 times the square root of z over the cube root of y. Oh, whoa, whoa, whoa. So we applied the power, then we worked it from left to right and applied quotient and product. And then we cleaned it up and wrote it as a radical. No questions, no comments, no concern? Cool. All right. I would like for you to try it. He's probably really not doing anything. All right. So working from, first start off with the power, right? I'm going to turn everything into a power. So you should have done log base 5 x to the 6 plus log base 5 4x minus log base 5 z to the 3/2. Good? And let me start from left to right. So from left to right, I'm going to do, I have product first, right? So I have x to the 6. I don't know why I wrote that so up there. We have x to the 6 times 4x. And then we're going to divide by z to the 3/2. And we're going to keep simplifying. So x to the 6 times 4x gives me 4x to the 7th. So we have log base 5, 4x to the 7th. And z to the 3/2 means the square root of z to the 3rd. How do we do? It's not terrible, right? You just got to follow the rules. All right, so base change. So the next topic for here is base change. Now, base change is important because in our TI-83s and 84s, you cannot just have any base that you want. It's all based on common log. So when we're doing base change, this is the pattern and rule that you follow so that you can input it into the calculator. So the base, you don't have to worry about the B, the green part, because it's automatically going to be the common base. Does that make sense? So in the calculator, the green is already, it's 10, which is our common log, okay? But the base of the original becomes the value in the denominator, and your original, this value becomes the numerator, pretty much. So let's give it a shot. So if I have log base 6, 33, and I want to be able to put this in the calculator, I'm going to have log, because remember it's common log, and my base value goes in the denominator, and this becomes in the numerator. And this is what I can put in the calculator. So in the calculator, I now can put in, so I have log 33 divided by log 6. And I get approximately, is it near hundredths, right? Yep. 1 in 95. 1 in 9,500. Easy enough. So let's do a couple more. So here, before I can put it in the calculator, I'm going to simplify it. So I'm going to simplify first. Because of the subtraction, I know that this is a quotient problem. So simplifying it, I get log base 2, 6 divided by 150. 6 divided by 150. I can literally leave it like that since I'm putting it into the calculator. I don't have to change anything. So in the calculator, it's common log. So I have my common log. And this becomes my denominator. And this becomes my numerator, 6 divided by 150. And that's what we're going to put in the calculator. So I'm going to go back to my calculator. And I'm going to type in log 6 divided by 150 divided by log 2. And hit enter. And I get my value, and my value is -4 6/400. So my solution is -4 6/400. Now, could you clean this up if you really wanted to? You wanted to write 3/50? Sure, go for it. But is it going to make a difference if you're inputting in the calculator? Not at all. All right, next. So again, calculator. If I have log base 2, 1 minus x to the third minus x equals e to the x. Well, I can graph e to the x. The problem is log base 2, I cannot graph. So in order for me to solve this graphically, I have to use change of base. 1 minus x to the third minus x. So change of base, it's going to be log denominator, numerator. And this is what you're going to put in for your y1. And e to the x is going to equal your y2. And their intersection is your solution. Okay, so let's put it in the calculator. So I'm going to go to y1, and in y1, I'm putting all of that. So I have log of 1 minus x to the third minus x, close, divided by log 2. That's my y1. And then y2, I have second e to the x. And now I have y1 and y2 in. I'm going to hit graph. And where they intersect is my solution. So to find the intersection, I'm going to hit second, trace, see where it says intersect. So I'm going to press 5. So second, trace 5. And it's going to ask you, you want this curve? Yes. You want this curve? Yes. You want me to tell you the answer? Yes. And so my x equals negative 0.456. So x equals negative 0.456. How do you feel? Easy, right? 5.5 is not terrible at all. And that is it.